and welcome back. In this video, we will set up a parametric definition to model the Jacob's Ladder sculpture by Gerry Judah. This is an iconic sculpture which consists of multiple varying quadrilaterals from top to bottom. They vary in sizes and also their extension beyond the normal quadrilateral boundaries. To begin, we will start by constructing a point at the origin. We can use the construct point component and use a slider to assign 0 to all three coordinates. And that's our center point to begin with. Now, the first thing we need to do is to copy these points multiple times as we move up. We copy these points because this point will serve as the center point for creating quadrilaterals. For this, we need to create a number series. So we go to sequence, series. Let's assume that the height of each of our members is roughly 100. So I'm going to set this to 100. So that's step of 100. And the number of count, let's make it flexible. I'm going to start with 250 at the moment. This gives us a number series between 0 to 24,900. We use a z vector and use the move command, which is under transform Euclidean move. The geometry we want to move is the point, and the motion vector comes from the series of vectors. And that's where we have our points. Now, the next thing to do is to create a set of polygons around it. Now, the reason why we choose to make a polygon and not a rectangle is if you look at the rectangle component, and if we feed this as the plane and we set the x and y dimension by using a slider, let me change this to 10,000. If we use this, and scale it up, notice how the rectangle is being formed from the corner. What we would like to do is use these points as the center point. So in order to do that, we delete this, go to the curve parameter, primitive, and choose polygon. We use these points as planes. We will set a radius for now as 10,000, and the number of segments will be defined to 4. And that gives us our quadrilateral. This also gives us freedom to change this form from a quadrilateral to a pentagon or a hexagon, but that's for later form finding. Just going to hide all these preview. Now, what we notice over here are two additional things. One is the varying size of these polygons. That means our radius needs to vary from top to bottom. In order to do that, let's create a range of numbers between 0 and 1, and that we can use with a graph mapper. So we go to set, sequence, choose range. Now the default domain is between 0 and 1, and that's fine with us. The number of count is supposed to be 249. That's 249 because the output is always one number more than the number of steps that we use as input. So we can use a mathematical operator with a subtraction. So that's 250, and that's 1. So we get an output of 250 values. Now these values start from 0 and goes all the way till 1. At this point, we will use a graph mapper. So we can go to input, get the graph mapper. Now within this graph mapper, we need to right click and choose the graph type as Bezier. If you're new to the graph mapper, what this does is it takes the values that we have over here from 0 to 1. It maps the values of 0 to 1 on this x-axis and then uses the y-axis to feed the output value. So currently, if this is a straight line, you will get the same result as you feed in, but as you start moving these curves, you start getting varied results. So looking at this graphic, what we would like to do is start with a higher value, then increase it midway, and then decrease it all the way over here. So let's say we start the graph somewhere over here, which increases in size and then reduces. And you can use these handles to affect these minute changes in the graph. That looks fine for now. So let's read the output, and we have an output starting from 0.29 all the way to 0. Now probably we don't want it to be 0, so let's increase it slightly. Yeah, that seems fine at the moment. Now because these values are small, we need to multiply it with a factor. So let's assume that our base rectangle would be 10,000 that we had set over here. And let's feed this into the panel. So all our result from the graph mapper has been scaled by 10,000. And if we feed these values into radius, and enable the preview, we see the variable rectangle size over here, which can be varied based on the graph mapper. Disable the preview again. The next thing that we notice in this image is that these quadrilaterals also twist around an axis. And the axis does not seem to be aligned to the center of the bottommost quadrilateral. So an additional step to this would be to take these polygons and rotate it around a point which would be somewhere over here. To do that, let's take our starting point and move it by a distance of let's say 1,000, and that's the point or the axis around which we will be rotating our polygons. To rotate the polygons, you go to transform, Euclidean, rotate. That's the geometry. And this is the point along which we want to rotate. So that forms the plane. And we need to feed an angle of rotation. Now, since the angle of rotation is not uniform in this image, we will create another graph mapper that will feed out values which will be mapped to get the angle of rotation for this particular component. So we take these values, we multiply it with pi, because ultimately we want the entire quadrilateral to rotate by 180 degrees by the time it reaches the topmost point. So we go to math, get the pi value over here, and we feed this into the pi, and that gives us our angle in radians. Now we need to do a couple of adjustments. One would be to reduce our base radius by from 5,000 to somewhere around, from 10,000 to somewhere around 5,000. Okay, that looks pretty good. Now we can play with the graph, and we can also play with this rotational graph. And an additional modification could be to move the point of rotation further away. So I'm going to set it to 2000. And to really get this fine, thin, pointed top effect, let's just move it slightly in this manner. The benefit of setting this in using a graph mapper is that you can tweak the shape as you want. So let's just proceed with this shape for now. And let's see how to create these additional extensions. So once we have our quadrilaterals as polyline curves, use a curve geometry parameter and explode these. When we explode a polyline curve, which consists of 4 edges, because it's a quadrilateral, the output we get is a branched list with each list or each branch consisting of 4 line segments. If we notice the image, each layer of quadrilateral has been broken down into 2 sets of rectangular extrusions. So for this bottommost one, we have 2 line segments in this direction, and the next layer has 2 line segments in the opposite direction, and the subsequent layer is following the, so it's an alternating pattern. In order to do that, we need to extract curve 0 and curve 2 from the first branch, then curve 1 and curve 3 from the next branch, then 0 and 2 from the next branch, then 1 and 3 from the other branch, and so on. We can do this using the dispatch component. Use this list and feed a dispatch pattern. Actually, we don't even have to feed a dispatch pattern because the default pattern is true and false. That means this pattern will set 0 to list A, 1 to list B, then 2 to list A, 3 to list B, and so on. If we connect list A and list B into a panel, we can see that 0, and don't be confused by the index 1 because it's just renumbering index 2 from this list as index 1 over here. To see it on this particular geometry, let's just hide all the other components, and if we bring in a curve parameter and hide this as well, you can see we have index 0 and index 2 in one list, and index 1 and index 3 in the other list. Now within this, we want to extract branch 1 from this list, then branch, so that's branch 0 from this list, then branch 1 from this list, then branch 2 from this list, branch 3, and so on. So we need to alternate this pattern as well. To do this, we will firstly take the number 250 and create a simple number series. So that's the count. The step would be 1 and start would be 0. This gives us a number series between 0 to 249. We take this number series and we dispatch it as well. By dispatching it, we get an alternating pattern in this list as well. Now, we use a command or a component called tree branch. What this component does is it works like list item, but rather than extracting individual index, it extracts branches based on the path we feed over here. So we take this list, and at the moment this list has this branch which has 3 hierarchy of path. We will use simplify to bring it down to 1, and now we can use these simple numbers to extract the respective branches. Feed it over here, and we do the same for list B. So that's list B. We simplify this, and this. We take their respective outputs and merge it. Hide preview for all the other components, and what we get are alternating line curves. Once we have these curves, bring in a curve component and store all these merged curves into that. The last step would be to elongate these curves. And these elongations would vary from bottom to top. So what we can notice over here that the elongation at the middle portion is the maximum, and then it reduces at the bottom and at the top. We can use another graph mapper to control these varying elongations. So we use the same range, same graph mapper, and this time we will use these numbers, and the elongation will be based on the size of the line itself. What I mean by that is, let's just take these numbers for now. Let's take these curves and let's find the length of all these curves. So all these curves have specific lengths. We multiply this length by this number, and notice this is a graphed list or a branched list, and this is a flattened list. So we need to graph this, and that's where we get the first index or the first branch multiplying with the first branch of this list. We use a command called extend curve, where the curve input comes from here. The extension type is set to line by default. The start and end requires the length by which we want to extend the curve. So now this number series is going to act as the extension of the start and the end. If we zoom out, we can see that the curves are elongated based on their multiplication factor. If we would remove this, it would follow the length of the curve itself. So this multiplication factor is helpful. Now we can vary this again by moving the graph as we want. Increase it, decrease it, completely up to us. Okay. Once we have these curves, we need to turn these curves into rectangular extrusions. We can do that by extracting a perpendicular frame. So bring in the perp frame command, that's the curve, and set the parameter to 0. And reparameterize the curve, and we get a set of frames around which we can create a rectangle. Now over here, we will use the rectangle command. So let's go to curve, primitive, rectangle. That's the plane. For X and Y, we will take the original size that we had set, which is 100. So we take this number into a number component and bring it all the way forward. And before feeding it in over here, because remember, it creates a point from the corner, or it creates a rectangle from the corner, and we want to treat this point as the center point for the rectangle. So we get a rectangle in this manner. To do that, we need to construct a domain where the start needs to be -50 and the end needs to be +50. If the number or the size of the rectangle is supposed to be 100. So we take this, multiply this with 0.5 and use a negative multiplier as the start domain and end. So our domain now is -50 to 50. Then feed this number into X and Y, disable preview for everything else, and we get our rectangle. So that's the geometry, and the extrusion vector can be derived from the curve. So we take the curve, find the endpoints of the curve, and create vector 2-point from start to end. And use the extrude to set the rectangle and the direction. To visualize this properly, we will use custom preview. Use this as geometry and use the swatch, color swatch. Set this to white. We can change this to rendered preview and hide everything else. Once the definition is set, you're free to move all these sliders. So we can set the rotation point to perhaps 4,000 away from the center. We can increase the amount of rotation. So if we want, we can multiply this with 2. So the rotation would be for 360 degrees. So we have a more drastic rotation angle over here. We can play with our graph. Or we can also reset this graph. Perhaps this is too drastic. Maybe edit this. Yeah. And another interesting thing that can be done in this way is to set or change the number of polygons from 4 to, let's say, 6. And the definition is completely parametric, and we have a hexagon now instead of a quadrilateral. You can play around with this graph, control the sizes, That's the entire definition for you. Do try it out. Try it with various profiles. And for more such videos, please like and subscribe our channel, and see you in the next one.